Here are the X and Y inputs. Here's your XOR gate and your AND gate. XOR is the sum, AND is the carry. Let's take these guys and input them into the system and see what happens to the outputs. X gets a 0. That 0 carries down this line and goes to node 1 of the AND gate. So now it's at node 1 of XOR and node 1 of the AND gate. That was the 0. Now the other 0, the Y input 0, goes to node 2 of the XOR gate, but it also travels down to node 2 of the AND gate. So we have a 0, 0 on the XOR. 0, 0 on an XOR is 0. But that's just like addition. 0 plus 0 is 0, isn't it? Now, for the XOR, we should get these outputs 0, 1, 1, 0. Fine. But let's look at them in a mathematical sense. The AND gate should get 0, 0, 0, 1 for its outputs. But let's look at them as in a mathematical sense. All right? 0 and a 0 on the XOR, you get a 0. And you get a carry of 0. That makes sense because you have a 0 and a 0 now on the inputs of this AND gate. Let's go now to the second input row, a 0 and a 1. A 0 comes up here to node 1 of the XOR, and that 0 travels down here to node 1 of the AND gate. The 1 of row 2 now feeds into Y and goes to node 2 of the XOR gate, and it also travels down to node 2 of the AND gate. So now let's look at our XOR gate. We have a 0 and a 1. Let's add them up. 0 plus 1 is what? 1. 0 and 1 is a 1 with a carry of 0. And that has to be what's on the output of the AND gate, because for the inputs we have a 0 and a 1. 0 and a 1 to an AND gate gives you a 0 output. Wow, it's working very well. Let's go to the third row of inputs. Here we have a 1 and a 0. So now a 1 is on X, comes over to here to node 1 of the XOR gate, and the 1 travels also down here to node 1 of the AND gate. The 0, the Y, travels up here to the Y input. That goes to node 2 of the XOR gate, and it also goes to node 2 of the AND gate. Let's do the math. 1 and a 0 is what? 1 plus 0 is 1 with a carry of 0. Let's check this. 1 and a 0, that's an exclusive 1 on an XOR gate. That'll give me a 1. And then a 1 and a 0 on an AND gate will give me a 0. What do you know? Okay, let's go now to the last row of inputs. We have a 1 and a 1. First thing that happens is the 1 travels up here and goes to node 1 of the XOR gate, and then it travels down here to node 1 of the AND gate. Then the other 1, goes as Y input to node 2 of the XOR gate, and it also travels down here to node 2 of the AND gate. Let's do the math on this now. 1 plus 1 is 2. How do you write 2 in binary? 0 with a carry of 1. 0 with a carry of 1. And there you go. It all makes sense. By connecting up the XOR to the AND gate, you can build an adder circuit. What do you know?